All right, so they gave us this graph for velocity of particle P1. There's going to be two particles, so P1 and P2. And they told us that we have zeros at 0, 3, and 5, and then these horizontal tangents at 1 and 4. So letter A says, during what time intervals, if any, from 0 to 6, is the acceleration of P1 negative? All right, let me pull out my sticky note. Now I know I have F prime and F double prime, but this is like position, velocity, acceleration. They're asking, where is the acceleration negative? Acceleration would be the second derivative. That's going to be negative where the first derivative is decreasing. And usually they give you the first derivative, and that's what they gave us here. It's velocity. So we want where this graph is decreasing. All right, so this graph is decreasing from 0 to 1, and then also from 4 to 6. And we're going to say because, how did they label this? Did they call it V1? Is that what they called it? Yeah, function V1, velocity of particle 1, because V1 is decreasing there. How did that go? Did that one go all right? Are we used to using the stick-it note? Okay, I hope like I've sort of hammered that into you guys, so I hope that that's like been good. Because I feel like those are like automatic points, like when you get to go to write something like. All right, letter B, on the interval 2 to 3, is the speed of P1 increasing or decreasing? Give a reason. All right, you need to look at both velocity and acceleration. So if they are the same sign, even if they're both negative, that means speeding up, speed is increasing. If they're opposite signs, that means slowing down. All right, so let's look at V1. And what did they say? On 2 to 3. So from 2 to 3, that's from here to here. This is the velocity graph. So from 2 to 3, velocity is negative. It's below the x-axis. So V1 is negative because the graph is below the x-axis. You wouldn't have to say that. I mean, unless you really wanted to be real thorough. I'm just writing that out to give an explanation here. This is the velocity graph from 2 to 3. It's below sea level, so negative. Do not write sea level on your AP exam. They're not going to accept that. I just say that to be silly and help you remember. All right, acceleration, and that's the second derivative. If your velocity is increasing, that means acceleration is positive, decreasing means negative. So from 2 to 3, so from here to here, velocity is increasing, and so that means that acceleration is positive. And that's because the graph is increasing. All right, so one of them's negative, one of them's positive. That means you're slowing down. Speed is decreasing. So speed is decreasing on the interval 2 to 3 because V1 and A1 are opposite signs there. So remember, for speeding up and slowing down, you have to look at both velocity and acceleration. All right, this next thing was interesting. I've never seen this done before, and they did this on all the free response on the testing app questions. So I'm wondering if this is like foreshadowing for what's going to be on your exam. They stuck a multiple choice question right in the middle of a free response question. I've never seen that ever. They've never done that. So I'm wondering if that's something that they're going to do this year. I have no idea. But they did it on all of the free response. Yeah, I liked it too, because it lets you know like you're on the right track. Like if you work it out and your answer's there. So I don't know. This year's exam is a total mystery. Like you guys are gonna have to tell me after you take it, like what it was like, because I have no idea. My prediction is that you're gonna do a lot of essay writing and explaining things. And then my next best guess is it's gonna look like this, because this is what they put on the testing app. So anyway, it's cool. There's a multiple choice question right in the middle of this free response question. The second particle, P2, is also moving from 0 to 6. Position is given by this. So they gave the position function. It's not going to be pleasant. It's going to be nasty, right? Identify, and so we're going to get a calculator for this. I apologize. I forgot to say that before you started working on it. This is a big disaster. You would get a calculator for this. All right, identify which of the following is a correct expression for velocity. All right, so let's find V2, velocity of particle 2. So if this is position, to get velocity, we're going to do a derivative, and this is going to be a product rule. This 2.7t is the first function. Sine of all of this is the second function. I'm not even going to worry about the minus 0.9 because that's a constant at the end there. So that's going to go away anyway. We're just going to do a product rule with this part. All right, so it is the first function, 2.7t, times derivative of the second. So derivative of sine is cosine. You're going to have cosine of all that. And then you have to chain rule on the derivative of what's inside, which would be 1.25. So 1.25 cosine of all of that. So it's first times derivative of the second. That involved a chain rule. Plus the second function, that's that sine of all that stuff. And then times derivative of the first, which would just be 2.7. All right, so we have to pick which one of these looks like that. And I'm remembering this, they wrote it the other way around. And it's a lot to sift through, but we know it's not Q or R. They stuck an integral in those, so we can narrow down. It's not going to be those. I think they wrote it the other way around. 2.7 sine of all that stuff plus 2.7t, 1.25. Okay, yeah, so it's U. U is the answer for that one. Now, I don't have a scoring guideline for this, but I like to believe that would be worth a point, like if you picked the right one. All right, so let's see what else they want us to do. Identify which is the correct expression for the velocity of particle 2. Then determine whether this particle is moving left, right, or not at all at times 3 and explain your reasoning. All right, we're going to find the velocity at 3, which we're going to type that in our calculator. We're going to plug 3 into all this. If it comes out positive, that means moving to the right. If it comes out negative, that means moving to the left. And if it comes out 0, that means the particle's at rest and it's not moving at all. All right, so let's plug in 3 to this gigantic mess. All right, 2.7 times 3, and then times 1.25 cosine of 1.25 times 3 plus 2.9 close parentheses. Hold on, did I start another parenthesis that I need to close? Yeah, I did. I started another parenthesis there. All right, close the other parenthesis. Plus, and then sine of 1.25 times 3 plus 2.9 close parenthesis times 2.7. Phew. All right, and if you button push any of that wrong, it's not going to come out right. So I hope that that is right. 10.419. But the point is that it is positive. So they asked moving left, right, or neither. If this comes out positive, that means moving to the right. Positive velocity means moving to the right. So P2 is moving to the right at times 3. That's what we plugged in because the velocity of 3 is greater than 0. You could say is positive there, however you wanted to word that. All right, and then last one, determine whether P2 is moving toward or away from P1 at time 3. All right, there's kind of a lot you need to look at to get that. You need to find out where both the particles are and which direction they're moving. So for example, if one's here and one's here and they're moving this way, they're going towards each other. If one's here and one's here and they're moving this direction, then they're going away from each other. So you have to figure out where they are and what direction they're both moving. All right, so first let's do P1. P1 is at what position, what time did they give us? At times 3. I think they wrote that in here. Yeah, at times 3, it is at position 8. So P1 is at 8 at time 3. So that is where P1 is. And let's see what its velocity is. And velocity at 3, did we have that? Oh, we are given the graph for velocity. Velocity at 3, oh, that's 0. So that means that that particle is not moving. So it's at 8 and it's not moving. So that's cool. At least one of them is still. If one of them is at rest, that's kind of nice. All right, P2 is at, and let's find out where P2 is. Let's find that position. Sorry, I'm moving this around so much. I have to go around and find all these equations. All right, here's the position for particle 2. We're going to plug 3 into that. So we're going to find out where this particle is at times 3. I'm going to plug in 3 to this position function. All right, so 2.7 times 3 sine of 1.25 times 3 plus 2.9 close parentheses minus 0.9. All right, so that comes out to 2.005. So that's just where the particle is at times 3. And then we're going to get the velocity at 3. Didn't we just do that? Velocity at 3, wasn't that 10.419? All right, so that particle is at around 2. We'll just call that 2. And moving to the right. So if you think about where these are, here's 2. That's where particle 2 is. And here's 8. That's where particle 1 is. Now, particle 1 is staying still. So it's just staying put right there. This one is at 2, close enough. And it's moving to the right. The velocity is positive. So the question was, for all of that, the question was, determine whether P2 is moving toward or away from P1 at time 3. Well, it's moving towards it. So P2 is moving toward P1 at time 3 because and I would just kind of write out I can't hold on to all these pieces of paper. I would kind of just write out everything that we said here because P1 is at 8 and at rest, and P2 is at 2.005 and moving right. Again, I think you're going to do a lot of essay writing. I would just take everything that we did and kind of write it out in words. P2 is moving towards P1 at that time, at time 3, because P1 is at 8 and it's still, and P2 is at 2 and moving towards the right. So it's moving towards the other particle.